What is going on with this Apple 2GS? Let's take a look. Okay, we got a duo disc in slot 7, a joystick. We've got a floppy emu card up here. And we've got an ADB going to a USB Wombat. What's that? And what's the Wombat going to? A dongle for the keyboard and the mouse. And then we got the monitor going up here. And what is this thing? What are those wires? They're coming from the interior game socket using these nice little connectors that plug right into it, into a breadboard that I'll have to document. But there's LEDs, so there's a green, yellow, and a red. Well, those are annunciators, 0, 1, and 2. There's a chip in the middle. That is a quad NAND gate. And then there's a MIDI socket. See those little orange wires? That's so you can have access to pins 2, 3, and 4 of the MIDI socket going to a MIDI cable. And the LED is taking annunciator 2 so you could see what I'm doing with it. Those are the interior pins on the game socket. And that's the old battery that came with the GS. And I replaced it with a Rayovac CR2 battery, but it's a little big. I couldn't get the cover on, so it would really need a smaller battery. And let's see here. Okay, so Annunciator 2 is where I did my homebrew MIDI circuit. So there should be a 220 ohm resistor in there somewhere. Oh yeah, there it is, going out. So it's really taking Annunciator 2, going through 2 inverters, that's what those jumpers are, and going to MIDI out. And let's test it. So on a wireless keyboard, we could type the number 1, and it appears on the monitor. Wow. Steve Wozniak would be happy. And it runs the floppy disk. And press return to play the chord. Wow. Okay, if you build that and you hear that, you'll be amazed. Okay, so now let's run startup. Do one more test. Okay, MIDI lights, because the MIDI is going to this Yamaha Easy Guitar. So if I type 3 to run the MIDI lights test, it is going to send MIDI commands to the guitar, and it's going to turn on this array of 6x6 lights that you could use to display chords on the guitar. And turn them off. So any enterprising educator can do something with this. But now let's test the MIDI Format 0 player. So here, no, I want to Control C. Now Control Reset is Control Print Screen. Okay, and for Open Apple and Solid Apple, I use the joystick. So I use Solid Apple Control Print Screen to get into the control panel on the GS. But now let's go back and run the MIDI player. Okay. Okay, so the songs are on disk images on the floppy emu. And they all have a slash MIDI volume. So all the disk images are 140K disk images on the emu. And if you hit enter, it'll catalog the emu. You'll see that in a minute. Yeah, so that little LED blinking is a catalog. And here are the files on this. And I'm going to play Peanuts. And these have to be MIDI Format 0 files, so you can edit them on a PC. I use PowerTracks Pro Audio, which is now called RealBand by PG Music. And then I save them as MIDI 0 format files. And then there's some options, but basic options, this is what you get. I got to fix the bug where the number 1 is missing. Now, did you notice how there was a slight timing anomaly when it did those chords in the upper register? Well, that is because the current program is running at 1 megahertz and using the Apple FCA8 wait routine. So this can easily be improved either with interrupts or by interfacing to an Arduino. So the reason there are some extra pins that I'm taking out on the internal socket is because I want to interface it to this Arduino to data logger shield suggested by David Schmenk in a blog post. And it's a 4-wire interface that will get the signals from the Apple into an Arduino. And then I want to do SPI communications to get the milliseconds from the Arduino back to the Apple, so the Apple can send a message saying, give me the time, and it will send the milliseconds back. And then the machine language driver can use that to determine when the next time is to play the notes. And it can see if it's over the time or getting close to the time. So you could tune the durations that way, and then you'll get better timing. Okay, so come to Kansas Fest 2018, and I hope to have some good demos ready. Thanks. Now, what about you poor Apple IIc users? There's no internal joystick socket, but you do probably have a port for an image writer cable like this. And since that works with ADT Pro, I can get a 25-to-9 adapter and grab those pins, and if necessary, use a null modem or a gender changer and interface to something. Well, that something could be a max 3232 driver, which will convert the logic levels from the 12 volts that comes out of RS-232, I believe, to 5 volts for the Arduino, and that's the pinout, so you got to keep your pins straight. And so I could get the 9 signals into a breadboard. I can get the MIDI 3 pins for MIDI out, and what was that? 4011 for quad NAND gates for logic. And so this looks like the way the Max 3232 works. And let's see, this is the internals, I think, of the... oh, this is what the chip is on the Max, those little SMD soldered pins. This is really what's going on inside of it. And this is the 25-to-9. So these are the RS-232 signals that I could use, because this image writer cable, it only uses 6 pins. And those are DCD, RXD, TXD, DTR, GND, and DSR. So you can't get hardware handshaking with RTS and CTS. So I'm going to look at some ADT Pro source code to figure that out, how to do the communication properly. Now for the Arduino, I could use the data logger shield. I could do the millisecond timing, or I could try using this MIDI shield. So it comes from SparkFun. You have to solder in the components on the top and the headers. And I'd like to play either with an Arduino Uno or a Mega. So I probably need a power source into the Arduino, either a 9-volt battery or 4.5 volts. Well, for this thing, it looks like you have to do 3 volts to 5.5 volts. So I'll see if the 4.5 volt works. And other things I could experiment with are the SD shield and the RS-232 shield. All right, so the basic idea is the Apple IIc will send a message, like maybe a Control-T command to get the time. The Arduino would look for a Control-T character and get the milliseconds. Now it could send it like as 4 bytes, or it could send it as a variable length quantity if I keep letting it grow and leave it on for 25 days. But really. I could also have like a 0 command, like to zero out the counter on the Arduino and then just send me the number of milliseconds since it was zeroed out. All right, and so then the Apple would have to grab that message. So once it sends the message, it would go into a loop waiting to receive the message from the Arduino. And then it would get it into a register, a 4-byte register that the code can check to see what time it is. Is it time to send more MIDI notes out? So since it's going through RS-232, then, I mean, I should use the Arduino pins to do the MIDI. So what's nice about this MIDI shield is I could do MIDI in or MIDI out. They give you the opto-isolator on the shield, so you don't have to worry about frying your Apple. Okay, and it has some buttons and 2 potentiometers hooked up to specific pins on the Arduino. And like to program it, you have to use a switch. There's a switch on here to do program or MIDI so that you could share the same output port. On the Arduino Mega, you have a bunch of serial ports that you could play with, so ultimately it probably would work better on a Mega, but this is to be determined later.